Hi everyone, I am Ammar Ali representing the University of Bedfordshire, and today I'll be explaining y'all on the plausible scenarios on the solar energy industry in Sri Lanka. Let's look into the contents first. This presentation will be basically focusing on few important topics such as the overview of the solar energy industry, the trends in the solar energy industry, the uncertainty matrix. Future plausible scenarios will be presented using a two-dimensional grid. The most plausible scenario will be identified and justified. And finally, I'll be concluding this presentation with references. So let's move into the overview of the solar energy industry. So what is solar energy? It is a type of energy which is directly obtained from the sun free of cost, absolutely non-polluting. So, when we consider the solar energy industry in Sri Lanka, it is one of the fastest and most promising growing renewable energy industries. According to the International Energy Agency, the solar industry is expected to grow by 15% by 2030 and 30% by 2050. Currently, Sri Lanka is having about 25,000 consumers of solar energy. Meanwhile, the Sri Lankan government is planning to increase the market size to 1 million consumers during the next following 10 years. Here, I have listed the key competitors of the solar energy industry in Sri Lanka for your reference. Now, let's look into the trends of the solar energy industry. Today, with the increased use of fossil fuels, we are facing adverse effects such as climate change and global warming. A popular alternative for this problem is to use renewable energy such as solar energy, which has many environmental benefits leading to sustainable energy generation. Hence, the solar energy industry is growing rapidly, where the Sri Lankan government has planned to achieve the 100% renewable energy scenario by 2050. Also, switching from the existing fossil energy technology to solar energy technology is a big challenge for consumers, mainly due to factors such as perceived cost, awareness of the technology, and perceived ease of use. The emergence of SEVs has greatly contributed to reduce the greenhouse gas emissions and energy consumptions. With the increasing of floating solar power plants, the solar capacity has increased drastically from 70 megawatt power to 1300 megawatt power. This technology has helped to reduce energy loss, evaporation loss, and as a solution for land constraints for energy production. Many institutions have come forward to financially support to mitigate climate change. So, let's move into the key trends of the solar energy industry. When we consider the cost of solar technologies, it is expected to fall in the future due to high technological advancements and cheap raw materials. It is observed that over the past 10 years, the cost of solar panels has declined by more than 75%. Also, solar panel installations have been increasing on buildings. This helped immensely to reduce the greenhouse gas emissions by 36%. Through solar installation programs, Sri Lanka has planned to install more than 1 million solar panels in the next following 10 years. Many governments have supported the solar energy industry by exempting taxes and offering tax incentives on solar products. Also, they supported the investors, sellers, and consumers by imposing safe and less restricted solar laws. After analyzing the key trends, the uncertainty matrix was used to identify the key uncertainties of the solar energy industry. Technology and cost were identified as the two key uncertainties as shown on the given table. Using the above two key uncertainties, a dimensional grid is drawn to develop four plausible future scenarios. The x-axis of the grid represents high and low streams of cost, whereas the y-axis represents high and low streams of technology. In this grid, the high technology refers to the latest solar technologies used in the solar energy industry, whereas the low technology indicates that there are no improvements in the technology and the technology remains constant. Cost in this grid is referred to the price levels of the solar energy, technologies, and products. Now, let's take a look at the four plausible scenarios of the solar energy industry which my analysis works with. These scenarios are Stone Age, Middle Age, modern era, and golden era. In the first scenario, the Stone Age scenario, it emphasized the situation where the technology has no improvements along with the cost of solar energy remaining the same. In this scenario, the organization in the solar energy industry might face quick revolutions and unstable movements. However, the industry may keep going forward silently despite the outcomes and consequences. Plausible situation might be a safe game for the major players, but the majority of the minor players may fall into a trap. Both the players will force themselves to satisfy their own situations and have no intention to bother one another at all in terms of improving the technology, improving the quality, cost of conversions, environmental factors, and healthy safety measures. Both the parties will force consumers resisting for change to other alternative energy resources due to low technology and lesser products. Technological advancements are vital in order to be effective and efficient to produce high economies of scale. Lack of technology would increase the cost of alternatives. Although low cost makes scenario attractive, usage of low technology is a deterrent. The middle age scenario assumes a dramatic change in the cost of solar energy technologies while technology remains constant with no any signs of improvements. Price will affect in a forceful manner regardless of the alternatives available. Thus, the industry will be sinking gradually and eventually lose the market share. As the demand drops, we might see a price reduction in the market, yet the society will have no intention to purchase the products due to low technologies. This scenario will be very critical for smaller players in the industry, which could lead to bankruptcy and eventually exit from the industry. The unwillingness to adapt to latest available technology and due to high cost, the consumers will be forced to shift to other energy sources. The reluctance to change and improve technology will have consequences. Past incidents are plausible to repeat regardless of industry or product base. For an example, Nokia's reluctance for change to new technology threw them away in business. The modern era scenario assumes dramatic changes in both technology and cost. Given that the technology plays an important role for industry's efficiency, solar industry organizations are already running through digitalization, sensing growth opportunities in various perspectives. The industry determines to pump heavily on digital technologies and research developments such as artificial intelligence, machine learning, supercomputing, automations, and etc. On the other hand, with the increase of technology, more alternative products will appear in the market. Although latest innovations and high technologies are used due to high cost involved, the business proposition does not look as attractive as it appears to be. There is a tendency to invest too much in innovation and developing something that does not sell due to absence of cost efficiency. Finally, the golden era scenario assumes there are rapid technological advancements in the industry despite the cost of solar power remains constant. Technology acts as a major driving force in solar energy industry, contributing significantly in terms of efficiency and effectivity. With innovations being at its best and with low cost of solar technologies, the industry is hungry for new technologies, resulting in enhanced yield of production. Many assume artificial intelligence is the future of technology. Artificial intelligence would help to increase productivity and create economies of scale. By using AI technology, the industry can explore new sustainable ways to present the finished products in terms of carbon less and convincing greener products. Assuming the industry abstracts maximum use of this knowledge, it would help the industry in order to stabilize the price in future by various means. In other terms, the technological advancements would boost the industry in terms of productivity and decreased cost, which will eventually increase its profitability. Since the demand for the products will increase, there will be mass productions. With price being low, this scenario will dominate the future and monopolize the situations in all terms. From the above four solar energy scenarios, a key question shall be what is the most possible scenario for the solar technology industry in Sri Lanka? The answer to that question is the golden era scenario. This scenario has a clear vision in terms of the reality in current environment. Technology is increasing day by day, whereas costs are reducing with the advancements of technology. The technology is a hot topic in any industry, and we see a trend of developing overnight. Sri Lanka, being a tropical country located closer to the equator, has all the potential resources for solar technologies, which is a very positive factor. With the increasing climate change in Sri Lanka due to high greenhouse gas emissions, people are moving towards greener products. For green production, high technology is vital. Also, with the rapid development of global technology through investments, Sri Lanka is also striving forward to experience these modern latest technologies. Sri Lanka, being a developing country with lower middle income and high level of public debts, affordability has been a major reason when considering solar power installation in Sri Lanka. It is due to high initial installation cost of solar technologies when compared with other conventional technologies. But due to the decreasing price levels of solar technologies globally and due to government support in promoting solar technologies, Sri Lankan people are finding it to be affordable due to lower cost. Therefore, the solar energy industry in Sri Lanka should focus on the golden era scenario as the most plausible scenario in order to strategically plan their internal capabilities for its survival. These are the references for the presentation. Thank you.